Okay, class, let's move on. This is where we left off at our last video, and we have two more columns to finish here for this table, and then we'll move on to, I'll show you what we're going to do with these columns, because like I had mentioned before, and I'm a man of my word, we're not going to do anything that is not useful for us. That is, we're not just doing this for the fun of it, right? Even though it's fun. So these two columns, the C here represents cumulative. So this is cumulative frequency column. This is going to be our cumulative percentage column. Okay? And what does that mean? Well, most of you are familiar with, if you take a class and the professor says we're going to have a cumulative exam, that means the exam is going to cover everything from the beginning right up until the time of the final, right? So we're going to accumulate this information. In this case, we're going to start at the bottom. We're always going to start with our lowest number here, 3. We're going to start at the bottom, and we're going to put our frequency in for, this is how many people told us they had a happiness score of 3. So at that point, there was 2 people, right? 2 people told us that they had a happiness of at level 3, okay? Then we're going to move up to here, and 2 people said that they had a happiness level of 4, but we're going to add that together with the number of people that said that they had a happiness of 3. So we take these 2 people and then add 2 to those. So this is going to be 4 here, okay? A little bit confusing. Don't just write the numbers down, okay? I want you to understand what's going on. We're accumulating these frequencies, 2 plus 2, and then we're going to add 4, and then we're going to add 13, and then we're going to add 15, okay? So 2 people said they had a happiness rating of 3. 4 people said that they were at happiness level of 4 or below 4. Everybody with me? So there's 2 people that said 3, 2 people that said 4. So we're at 4 people that said 4 or below 4. And I always like to put up here, this is, let me change this. This is at or below, okay? So 4 people had a score of 4 or below 4. When we get up to 5, that is our x value of 5, we have these 2 people, plus these 2 people, plus these 4 people. So what is our entry here? It's 8, okay? 2 plus 2 plus 4 is 8. So 8 people had a score of 5 or below 5, okay? So it's at or below 5. That is at or below 5, okay? At or below 4, and then we stay with 3, okay? Can we get the number for where we would be at 6 for our cumulative frequency, We have 8 in our basket already, okay? That's sort of how I conceptualize it. I'm going up this number line and I'm putting in the frequencies, okay? So 2 plus 2 more is 4, plus 4 more is 8, plus 13 more is 21, okay? 8 plus 13. So 21 people said that they were happy at 6 or below 6. That is at or below, at or below. It's very important that you understand this concept. And this is where people, and a lot of times, they can memorize rules for math. But if I said, well, what does this number represent? That's the number of people that reported 6 or below 6. That's the number of people that reported 6 or below 6. That is, they're at or below 6. Okay? What's the next one? we have 21 people. We're going to add 15. So this is 36. Okay. And 36 people, we're going to add 16. So that's 52. Okay. 52 people reported a happiness score of 8 or below 8. 8 or below 8. Okay, so this is a bucket. This is a basket filled with frequencies. And then 59. And then, of course, once we get to the top, this total cumulative frequency, of course, has to be equal to this. Okay? Now, I'll tell you why we're going to, why this column is important, but I want you to understand the difference between, let's say, for example, frequency and cumulative frequency. The frequency is how many are at each of these, okay, values. Cumulative is, this is how many people are at a happiness of 6 or below. At or below, okay? All right, so cumulative percentage is the same concept here, but I will tell you that I want you to get your cumulative percentage from this column. I mean, we could do the same thing that we did for frequency, for cumulative frequency. We could do it for percentages, just start adding these together. The problem is these are rounded values, and so sometimes whenever you round a number, it creates a little bit of error, right? So we're going to key our cumulative percentage. We're going to sort of key that from these numbers. Okay, we're going to use these numbers. So 2 divided by 61, that is, we want to know what the percentage of 61 this is. So 2 divided by 61. So our lowest number here, of course, is going to be the same as it was here because we're starting from the bottom. Then we have to do a little bit of an adjustment. So now we're going to do 4 divided by 61. Let's see what that is. 4 divided by 61, 6.56. Okay, 6.56%. Okay. And then 8 divided by 61, 8 divided by 61 is 13.11. Let me make sure I have these correct here, okay? 13.11, okay? And then 21 divided by 61, 34.43. 34.43. Now let's remind ourselves about what these numbers mean, okay? What I'm doing here is 21 divided by 61. That's the cumulative percentage there, okay? But what does that mean? I am going to ask you what these numbers represent, what they mean, in addition to having you do the computations. Yes, this is a challenging course, okay? I'm not going to apologize for that. So, what does this mean? 34.43 is our cumulative percentage when we're at a score of 6. That means that 34.43% of our people, 34.43% of this 61 people, are at a happiness of 6 or below 6. So this is also, whenever we have cumulative, this is at or below. At or below. At or below. Okay? That's the nature of cumulative. What percentage of the people reported a score of 6? Well, 21.31% told me that they had a happiness of 6. 21.31 told me that they were at 6. 34.43 were either at 6 or below 6. Okay, that's what the cumulative will do for us. I'm going to get to why that is important. okay? But for right now, I just want you to know the difference between this percentage and this percentage, okay? All right, so then we have 36 divided by 61, right? 36 divided by 61 tells us 59.02, 59.02% of our data set of the people reported a happiness score of 7 or below 7. Okay, 7 or below. That's what this does for us. And then 52 divided by 61, 85.25. And then 59 divided by 61, 96.72. Now, we don't even have to do the computations for our final entry because by the time we get up here, we have 61 people out of a group of 61. So this is, of course, and it will always be 100%. Okay? 100% of the people said 10 or below. 10 or something below it. Okay? If we had added these up here, we may not have gotten exactly 100. It might be 100.02 or it might be 99.97 or something like that. We know that can't be true. That is, this by definition is 100% because now we have all of the people. Okay? It has to be 100%. Okay? So, that's our table. And in fact, I'm soon going to get rid of this column. We don't need to do that right now, I don't think. But I go through this because, number one, you're in college and you should know that the relationship between proportion and percentage, so these are the same numerals, it's just where the decimal point is. Out of 1, if we add all these up, it's going to be 1. If we add all these up, it's going to be 100. Okay? But we're not going to use this much. This tells us the percentage of the people that reported each of the scores. That is, at the scores. When we get to cumulative now, we're saying at or below. At or below. Okay? And this brings up a good point because most of you have taken standardized tests, and I kind of say that with tongue-in-cheek because I know all of you have been taking standardized tests for many years, a little bit too much as far as I'm concerned, but that's just my opinion, okay? And oftentimes when you get your reports, whether it's SAT scores or some other standardized scores, you'll be given a percentile number. It'll say you're in the 84th percentile, okay? And oftentimes people misunderstand that number. They think that they got an 84% on the exam because we're so used to talking about tests with percentages. Percentile does not tell you how you performed on the exam in terms of your score. That is, if you're in the 84th percentile, it doesn't mean that you got 84% on the exam. What it means is that your cumulative percentage where you're at is 84. That means 84% of the people, whoever took the test, 84% of those people had the same score as you or below it. In other words, this column right here, I want to make sure I don't run out of room here. This column is our percentile column. Percentile means the cumulative percentage. That is the percentage of people that are at a particular point or below it. At or below. At or below. okay? Not at, and it doesn't tell you what percentage are at your score. It doesn't tell you your percentage on the exam. It says, this is the percentage of the people that scored the same as you or below you, okay? So finally, the mystery is solved. The mystery is solved. Because a lot of people don't know that particular statistic. So already you are more sophisticated now, certainly than you were a week ago, I hope, in that you can tell people what percentiles are. That's the cumulative percentage, okay? So for our example, if you said that your happiness was at 7, if you said your happiness was at 7, right, then you're at the 59th percentile. 59% of the people said 7 or below 7. Said 7 or below 7, okay? And that would mean only, what, 41% of the people reported a happiness higher than 7, okay? If you got if you were an 84th percentile in your standardized tests, it means that 84% of the people scored what you scored or worse, 84%. And then what would be left over? Only 16% of the people scored above you, okay? So that's percentile. That is the percentile. It tells you where you are at in a distribution relative to other people, okay? Excuse me. So that's what the percentile is, okay? I kind of want to rewrite this now. Let's see if I can do this without too much trouble. Yeah, let's do this. We're going to get rid of this, okay? We're going to get rid of this. Why don't you start a new page so we can make this a little bit cleaner? Okay, I'm going to get rid of the P column. I'm going to move this over a little bit. I apologize here. So I'm moving that over. I'm going to move these over. Again, I will remind you, if you have questions, please, make a note of your questions, and, we can talk about them when we have our Zoom meeting. Or you can email me, of course, always. Directly email me if you have questions. Put these in here. So these numbers tell us the percentage of people at each of the scores. At each of the scores. Okay. This is our mode because it's the most frequent. I'm going to bring this right over. Again, we're going to start with the lowest number at the bottom and go to the highest. That's the only way that this cumulative frequency column would work, because we're saying here or below, that is, or lower. If you switch these numbers so the lowest is here and the highest is here, it doesn't make any sense. You will never see me do that. You won't see it in the book. Please don't do that on the exam. Okay. So we're going to do this. And then we're going to bring this over here. Okay. These percentages tell you both of these at or below. Okay, or below. At or below. That's the nature of the cumulative frequency and cumulative percentage columns. Okay? And we left out that P column. I'm fine with that because we're really not going to use it much. Okay? Now, here we go. Okay? We talked about two measures of central tendency, and that is the mean and the mode. Oh, and those are measures of central tendency. I guess I might not have mentioned that. But descriptive statistics. The mean, the mode. Of course, we talked about highest and lowest, and we talked about n, and we talked about the range. Remember, the range is a single number. Okay. But now all of a sudden, we're going to talk about something new, and that is the median. Okay. So the median, by definition, okay, the median, by definition, is the 50th percentile, okay? The median is the 50th percentile. Remember, this is our percentile column here. Cumulative percentage is our percentile column, okay? So this is the 34.43 percentile, this is the 96.72 percentiles, and so on and so forth, okay? The median is the 50th percentile. It's a special percentile, and let's remind ourselves, this is the concept, okay? This is where people have struggled with this class because they think it's a math class. It's not a math class. We're using numbers. We're doing operations with numbers, but these numbers represent concepts, okay? That's the important part. The numbers represent concepts. Otherwise, just take a math class. They represent concepts there too, but here we're eventually going to get ourselves into doing some research and making some decisions. The 50th percentile, so what would that mean? The 50th percentile tells us the place in the distribution where 50% of the scores are at or below. Okay, let me say that again, but I want you to listen carefully, okay? We're talking about 50% here, the 50th percentile. That is the place where 50% of the scores fall at or below. It's the place where 50% of the scores fall at or below. That is, it's right in the middle of the distribution in terms of the number of people, okay, the number of people. So it's the place where 50% of the scores fall at or below. 50% of the scores in a distribution fall at or below the 50th percentile, okay? So I would say maybe the place, how about that? The place where 50% of the scores fall at or below. I'm going to ask you what the median is. If you say the 50th percentile, that's half credit. Everybody with me? Because it happens every semester, okay? The median is the 50th percentile. That is a fact. But then I want you to know, well, what is the 50th percentile, right? The median is the 50th percentile. The 50th percentile tells us the place in the distribution where 50% of the scores fall at or below, okay? And by the way, it has nothing to do with a 50% on the exam. You could have a 92% on the exam and still be at the 50th percentile. You could get a 32% on the exam and still be at the 50th percentile because we're counting people. We're counting people, okay? It's the place where 50% of the scores fall at or below, okay? And by the way, please don't memorize this, okay? because once you're in an exam, you memorize something. If you forgot that memorized material, you're out of luck. If you understand the concept, you'll be able to get it, okay? 50th percentile is where 50% of the scores fall at or below, and that has a special name. It's called the median, okay? All right, so we want to report the median in this case, but we have a little bit of a problem here. We have a little bit of a problem because if I ask you what the 59.02th percentile was, you could tell me it's 7, right? If I ask you where the 13.11th percentile is, you could tell me it's 5. If I ask you where the 85th percentile, 85.25 percentile is, you could tell me it's 8, right? But I want to know, in this case, what the 50th percentile is. I want to report the median, okay? And I can't just see that from my table. So I'm going to need to do a little bit of extra work here. And we can do it. I'm going to teach you how to do this, okay? Some of you may be familiar with doing interpolation. You know, if we were in a classroom, I'd say, how many people know how to do interpolation? And inevitably, no hands go up. Because people are like, I don't know what interpolation is. I don't know what interpolation is. And it's like, okay, well, let's see. I mean, maybe you do know and maybe you don't. Because a lot of people know how to do interpolation in a simple example, and I'm going to use this. And then we're going to learn how to do the technique and make things more, you know, be able to do it with more complex numbers. Let's do this. Suppose that you got up this morning and we're getting ready for class, and or let's say you woke up early, and let's say you woke up at 6 a.m., okay? I said you woke up, you didn't get up, okay? So you woke up at 6 a.m. and the radio's on, and the weather person said, well, it's 40 degrees out this morning at 6 a.m., okay? And you're like, you roll back over because you're not going to get up until 8 o'clock, okay? So you get up at 8 o'clock, and you're listening to the radio, and the weather person says, it's 50 degrees now at 8 o'clock in the morning. Okay? Everybody with me? My question for you then is, what do you think the temperature was at 7 o'clock? What do you think the temperature was at 7 o'clock? Now, by the way, I didn't ask the question, what was the temperature at 7 o'clock? I said, what do you think the temperature was at 7 o'clock? I mean, let's suppose you were sleeping. How the hell do you know what the temperature was at 7 o'clock, okay? What I want you to do is make a guess about what temperature you think it was at 7 o'clock. You know at 6 o'clock it was 40. You know at 8 o'clock it was 50. So what do you think? Most of you, I think, would make a guess that the temperature was 45. And in fact, that's what I would guess. Okay, that's certainly what I would guess. Why would we guess 45? Okay, well, because over here, we're halfway in between 6 o'clock and 8 o'clock. And so, if the temperature was 40 at 6 o'clock and 50 at 8 o'clock, if I'm halfway in between, I'm going to make a guess that the temperature was halfway in between. Now, am I right or wrong? I don't know, I was sleeping, okay? However, This is not just a stab in the dark. This is not just a wild guess based on nothing. I was halfway in between here, so I'm going to go halfway in between here. Okay? And this is called interpolation. This is called interpolation. And here's a word that scares people sometimes, but what does it mean? We have this pole, and we have this pole. And I want to know what's in between. So interpol, interpolation, okay? My guess would be that the temperature was 45, okay? That's all interpolation is, okay? That's all interpolation is. But what we're doing here is we're saying 1 hour out of 2, we're going to equate that to 5 degrees out of 10. These fractions are going to be equal. Yeah, that's the math part, okay? That's the math part, okay? Those fractions are going to be equal. If I go through halfway here, I want to go through halfway here. Let me ask you this question. What temperature do you think it was at 6:30? What temperature do you think it was at 6:30? Well, here we go again, right? So now we have 6:30 is only a quarter of this entire interval, right? 6:30 is a quarter of this entire interval, or it's halfway in between here. So my guess would be that the temperature would be 42.5. That would be my guess at 6:30. Everybody with me? Now I'm halfway in between here, okay? 42.5. That's interpolation as well. It's just we're looking at different points. Now, everybody with me? If you get that concept, I could say, what do you think the temperature was at 6:18? Oh my God. Well, I mean, so the numbers become more challenging, right? The math is a little bit more challenging. The concept is exactly the same. Or I could say, what do you think the temperature was at 7:30? At 7:30, my guess would be the temperature was 47.5. But I could also say, what do you think the temperature was at 7:51? Oh my gosh. Then it gets, it gets more granular, it gets more fine grained. But all of these procedures, they're called interpolation because we're starting with two poles that we know, and then we're trying to figure out something in between the two poles. Interpolation. Okay? We do make a very serious assumption when we do this. We make an assumption when we do this. Even if you got this answer in the beginning, or if that was your guess, 45 degrees, you were actually making an assumption. Even if you didn't realize it, you were making an assumption. You were assuming that the temperature was going up linearly between 6 o'clock and 8 o'clock. If the temperature went from 40 degrees to 49 degrees at 6:30, and then the rest from 6:30 to 8, that would be a nonlinear model, right? The temperature goes up like this, and then all of a sudden just goes like that, okay? To do interpolation, we do make an assumption of linear relationship in this case, okay? A linear relationship. Let me ask you this question then. What do you think the temperature will be at 8:30? What do you think the temperature, well, let me make it easier. What do you think the temperature will be at 9 o'clock? If we know these poles, what do you think the temperature will be at 9 o'clock? My guess would be that it would be 55 degrees, right? At another hour, it's going to go up another 5 degrees. That is called extrapolation. Extrapolation. What are we doing? We have our poles. This is our given information, right? And then I want to go beyond the poles. I want to go extra. polar. Okay, that's called extrapolation. When we look between two poles, that's called interpolation. Okay, you got that? That's a little sidebar to kind of inform you about what interpolation is, and it's an extremely powerful strategy, and all of the sciences use extrapolation and interpolation because sometimes we know some information, but we don't know what's between that information, so we use interpolation. We know some information, but then we want to make a guess about something extra, outside of what we know. That's called extrapolation. Okay? So, we're going to use this technique. To answer our question. What is the 50th percentile? What is the 50th percentile? Okay? So, let's set this up, and this is how we're going to do it. Okay? We're going to set it up like this. The question is, what is the 50th percentile? Well, I don't know that. That's what I'm going to get to, okay? But I do know some poles between which 50 lands, okay? That is, I have the 34.43 percentile. I have the 34.43 percentile. And I have the 59.02 percentile, right? 59, 34. And I know that 50 is in between that, right? It's just like the time and temperature thing. If I know what the temperature is at 6 o'clock and I know what it is at 8 o'clock, but I want to know what's going on at 7, then I'm going to do interpolation. And this is the same thing here. This is the same thing. And so the 59.02 percentile is what? 7. How did I get that? Look. Okay. What does that mean? 59%, 59.02% of the people told me they were happy at 7 or below 7. Remember, this is cumulative. Okay? That's cumulative. All right? I know what the 34.43 percentile is, and that is 6. 34.43% of the people report a score of 6 or below 6. 34% is here or below. Okay? So we're kind of set up with our time and temperature, and I'll show you how to do the math in a minute. But there's a little bit of a problem here, okay? Let's do a little bit of review in that regard. Is happiness a continuous or a discrete variable? That's right, we decided it was a continuous variable. We have some evidence of that from our data set, right? That people can be really, really, really close together in terms of their happiness, and there could be somebody right in between them. That is, happiness sort of follows a continuous number line, okay? And so we need to make a little bit of an adjustment here. And this is why. Let's see, I'm running out of board here, but we can do this. So here is our happiness number line, okay? And we have some people that reported a happiness of 5, and some people that reported a happiness of 6, and some people with 7, and some people with 8, and some people with 9, and so on and so forth. But this is just a segment of our continuous number line, okay? How many people reported a happiness value of 7? Well, there was 15 of those people, right? And in fact, those 15 plus these 13 plus these 4 plus these 2 plus these 2 ended up giving us this number, 36. That is, 36 people said 7 or below. That's how we got 59.02. But I want to focus right here. 15 people reported a happiness level of 7. When someone writes down 7 on their Likert scale, when they indicate they're at a happiness level of 7, I am not going to assume that they meant 7.000000. Okay? And in fact, some of the people that wrote 7, when we asked them to do a Likert scale from 1 to 100, they said 70. Some of them said 73. You can look on your sheet. Some said 75. Some said 70. Okay? And so what I'm going to assume is when they say 7, maybe they meant 7.000, but maybe they meant 7.2. Or when I say maybe they meant, what I'm saying is maybe they're at the happiness of 7.2. But if you're at a happiness level of 7.2, you would say 7, not 8, right? Or maybe they're at a happiness level of 6.8 or 6.9. Maybe they're at 7. Maybe they're at 6.9324. Maybe they're at 7.173. Maybe they're at 7.4. Maybe they're here. Maybe they're there, right? All of this stuff. There's 15 people there. Some of them, I'm assuming, are at a happiness level that's a little bit above 7. Some of them, I'm assuming, are a happiness level a little bit below 7. Some of them maybe are really close to 7. But of these 15 people, I'm assuming that some of them are above 7. So when I say 7 here is my 59.02 percentile, that makes me a little bit nervous because I know some of them are above 7. By the way, I think this is one of the 5 most difficult concepts in this course, okay? Because we're needing to think about reported numbers, not literally. When someone says 7, I'm assuming they mean around 7, okay? When someone says 6, I'm assuming they mean around 6, okay? But I'm not going to take that literally if the variable is continuous, because that means there's an infinite number of decimal places that I haven't measured, okay? I mean, when people say, how tall are you, Dr. Speck? I'm like, oh, I'm 6 foot tall. Well, I'm not exactly 6 feet tall, but I'm closer to 6 feet than I am to 6 feet 1 inches. I'm closer to 6 feet than I am 5 feet 11 inches, okay? So we need to start thinking about measurements as being imprecise when we have a continuous variable, okay? When someone says 7, they're somewhere here. But if their happiness level is above 7.5, then they really should be 7.5. If their happiness is above that, then they really should be reporting a happiness level of 8, right? And if their happiness level is below 6.5, then they really should be saying 6. Okay? Now, humans are notoriously bad with numbers, so, but theoretically, if you're above 7.5, you're closer to 8 than you are to 7, right? If you're below 6.5, you're closer to 6 than you are to 7, so you should say 6 or you should say 8. These two values then become what are known as the upper real limit for 7 and the lower real limit for 7. the upper real limit for 7, the lower real limit for 7. 7.5 is the upper real limit, 6.5 is the lower real limit. So, when someone says 7, I'm going to assume they're somewhere between 6.5 and 7.5. Okay? But then why am I saying 7 here, right? I have to be a little bit more careful. Well, what should I say? Well, listen, we have a little bit of help here because this is cumulative percentage. So what I'm going to do is I'm going to say anything at 7.5 or below includes all of these people. If I use 7, I might be missing out on some of these people. So when I do this interpolation, I'm going to do the upper real limit for this number. So 7.5 and below is my 59.02. Because otherwise, I need all of these 15. I need all 15 to make up a cumulative frequency of 36. If I miss any of these, this is not correct, this is not correct. As long as I get all of these, this is the number, this is the number. So to guarantee I get all 15 people, I'm going to use the upper real limit and everything below. Okay? This is a challenging concept, so take your time. You need to rewind the, go back and look at this segment again, look at it again, okay? I need to get all 15 of these, and 13, and 4, and 2, and 2, to get this number, to get this, okay? If I use 7 as that number, theoretically, I might not get some of those 7s because they're above 7.0. All right? So use upper real limit and everything below. Sometimes people are like, why don't we use the lower real limit? When I hear that question, I know that people are looking for a rule rather than thinking about the information. Because if I use 6.5 and below, I get none of these. And so this wouldn't be the correct number, this wouldn't be correct. Okay? Upper real limit and everything below captures everything. Okay? I mean, sometimes I use beer logic, okay? Let's suppose that we were going to go to happy hour as a class, and I ask someone in the class, hey, let's go to happy hour, are you coming with us? And they say, oh, I don't have enough money, how much are beers, and I say, well, I don't know, for happy hour, beers are 3 something. I'm not sure, it's 3 something. Okay, how much money would the person have to guarantee they could get a beer? Yeah, if they have $4, they cover everything that's 3 something. If they have $3.25, I don't know if they can get a beer or not. I don't remember what the beer is. It's 3 something, okay? If they have 4, they get everything in the 3s. If I use 7.5 here, I get all of the 7s. If I use 7, I'm going to miss out on something. Of course, if I use 6.5 and below, I get none of the 7s. Okay, so we want everything below 7.5 is going to include all the 7s, all the 6s, all the 5s. That's exactly what we want here. Okay? Now, the same thing holds true for 6. How many people reported a happiness score of 6? 13 people. And we needed those 13 plus this, plus this, plus this, right? To get to this, to get to this. Same logic here, okay? Some of those 6s are going to be above 6.0. Some are going to be below, and so on and so forth. So now, we have lower real limit for 6 is 5.5. Upper real limit for 6 is 6.5. When I'm talking about cumulative percentage, I'm going to use 6.5 and everything below. 6.5 and everything below. We're just going to use the upper real limit here for our interpolation procedure. Okay? Any number that is on a continuous scale, like happiness, when people say 7, or people say 9, or people say 5, whatever it is, I know that there's other information beyond that we just don't have the resolution to see. Okay? So this is what we're going to use. And by the way, sometimes people mistakenly think that upper real limits, you just add a half, lower real limits, you subtract a half. I remember learning this in school, and I'm like, oh, you just add a half, subtract it. No, it's halfway in between your most precise measures. It's halfway in between your most precise measures. It's not just 0.5. That's for whole numbers only. Let's suppose we go to a gas station. You're getting gas, right? We go to 2 decimal places. Right? $9.98, $9.99, $10, $10.01. Okay? If you and I both get $10 worth of gas, if we're both here, right, at the gas station, we both got $10 worth of gas. Did we get the same amount of gas? And we're talking about the same price, same pump, all that stuff. Well, the answer is, I don't know. Because amount of gasoline is continuous, right? I mean, it's a liquid. It's continuous. And you guys have done this before, probably, if you pump your own gas, right? And you're almost at 10, or it just pops off at 10. You're like, oh, I wonder if I can get just a couple more drops before it goes to 10.01, right? $10 covers a range in between what? 9.95, 9.995, and 10.005. Halfway in between 9.99 and 10 is where the pump's going to switch. Halfway in between 10.00 and 10.01, that's where it's going to switch. The most precise measurement on a gasoline pump is to the penny. But there's stuff in between there, right? Because gasoline is a continuous variable. So in this case, the upper real limit for $9.99 is 9.995. The lower real limit is 9.985, okay? And so on and so forth. Upper and lower real limits are halfway in between our most precise measurements. For whole numbers, it ends up being, 0.5. When we have 2 decimal points, then it goes to the next decimal. Okay? When you have a continuous variable, you can never measure it exactly precisely to 15 decimal places. Okay? So we have to be careful. All right. Wow. You know what? We've gone a little bit over time for this one. So for the next video, we'll complete the interpolation for the 50th percentile. Okay? And it goes quicker. Now that we know how to set it up, we're going to do a couple of these. But let's save that for the next video. And